Hi there, welcome back to my channel. In this video, we are coming to continue our discussion on investment appraisal techniques. And specifically, we are coming to look at the concepts of simple interest, compound interest, and annuities. Alright, and these concepts are very important, especially when it comes to dealing with discounted cash flow techniques. So we are coming to take our time to look at them one by one and see um, how they are calculated, and then also any issues that may be relevant as we progress through our studies. So brace yourself up and let's get started. All right, so we are going to look at simple interest first. So what's a simple interest? So we are saying that a simple interest is the interest that accrues only on the initial amount of money you invested in a particular investment account, or whatever you have put your money in. So that is what we call the simple interest. And now this is a very fundamental concept in finance. So you are not going to dwell much on it because there are no technicalities here. Now the formula for calculating a simple interest is this. So in order to find your future value, or what you call the amount, the total amount of your money in an investment account, what we do is that we take the principal amount and multiply it by the simple interest formula here. And then we are going to multiply that by 1 plus Rn. Okay, and the R here, the P, okay, is the principal amount. That's the amount invested, the amount you have invested. Okay, and then the R is the annual rate of interest, the annual rate of interest, and then the N is the number of years you have invested the amount, right, the principal. All right, so that is what we have there. So we are coming to look at compound interest as well. So compound interest is a specific form of interest where the interest is based on the initial amount invested plus interest accrued to date. So what you are saying is that with the compound interest, interest is earned on principal plus interest. Unlike simple interest where the interest is earned on only the amount invested, with a compound interest, interest is earned on interest plus principal. So that is the difference. And here is the formula. So you could see that it is the same variables, but just that the n um, is now a power. Okay, so we have the principal amount multiplying 1 plus the rate raised to the power n. Okay, and the various variables are the same. So that is the compound interest formula and meaning for you. So let's continue. So we have a work example here. So we have an amount of $10,000 is invested in a fund on 1st January 20x0. Required. Calculate the amount on deposit by 31st December 20x4 if interest is 1, 9% on a year simple, and then 2, 9% a year compounded. All right, so that is what we are having here. So first, to calculate the simple interest on this investment in the fund as at 31st December 20x4. So you are calculating the future amount. All right, so that's the future amount, and then you have to calculate the future amount as at this date on a compound basis. So let's look at that and see the solution there. So we have solution. With a simple interest, we have 9% simple interest. So the formula is the future value or the total amount will be equal to the principal, which is the amount invested, into bracket 1 plus Rn. Okay, bracket close. So you can pause this video, solve it on your own, and then you can continue the video and check the answers and see if you are correct. So it's just a matter of what substituting the values into the variables here. So our principal is equal to 10,000. Our rate is 9%, which is usually expressed as a decimal. Okay, 0.09, that is 9%. And then the number of years is from 1st January 20x0 to 31st December 20x4. So that is equal to 5 years. Okay, so 20x0 inclusive, 20x1, x2, x3, and then x4. So that is 5 years. All right. And then we are saying that the future value therefore is this. So we have the principal amount multiplying 1 plus 0.09, which is the rate, times 4, which is the times 5, sorry. This should be 5. All right. So there's a mistake there. This should be 5. Multiplying that. So that should give us an amount of 14,500 there. All right. So you kindly change this 4 to 5. All right. Now let's look at the second one, which is the compound interest. So it's the same thing, just that the formula has changed. So the future value is the principal amount multiplied by 1 plus r raised to the power n. So our principal remains the same, rate remains the same, number of years remain the same. The only thing is the formula difference. So this is the amount at the end of 31st December 20x4, which is $15, 386,000.24. All right, so that is what we have. Okay, so with that said, or with that demonstrated, kindly try this example. Leave the answers in the comment section or in my Telegram channel link that I'll be provided in the video description. All right, so kindly submit the answers through this particular means for me to check them out and provide you with the feedback that you need. All right, so this is the example you are supposed to try. $2,000 is invested on 1st January 20x0 in an investment account earning 10,000 interest a year. All right. $800 is added to the amount on 1st January 20x1 and a further 700 is added on 1st January 20x2. So you are required to calculate the total amount. All right. So that's a future value. Total amount on 31st December 20x2 if compound interest is 10% each year. All right. So let me just give you a few hints here. So we know that this is the amount, this is the initial investment, that's the principal at 1st January 20x0. Okay. So interest is going to be earned on this 2,000 from 20x0 to 20x2. All right. And then we've been told that on 1st January 20x1, this amount was added. So this amount will start earning the interest from this date. All right, from this date. And the same idea applies to the 700, which is on 1st January 20x0. All right, so it means this amount is going to stay in the account for a number of years. This amount is going to stay in the account for a number of years. And then this amount is also going to stay in the account for a number of years, which is actually 1 year here. So I'm going to leave this for you to try your hands on and leave the answers in the comments or my Telegram channel, or even you can leave it on my LinkedIn. Can message me on LinkedIn and then I can check it out and provide you with a feedback. All right, so let's continue. Now let's look at the concept of annuity. Annuities. So what is an annuity? Annuity is a very common term in finance, okay, in financial management. Now, annuity is a series of regular periodic payments of equal amount for a period. All right, so that is what we call an annuity. Annuity is a series of regular periodic payments of equal amount for a particular number of period. All right, so that is it. Now, for calculation purposes, we have two types of annuities in financial management. The first one is ordinary annuity. And with the ordinary annuity, we are saying that payments or receipts are in arrears. That is, they occur at the end of each period. Okay, so what you are saying is that since you are saying an annuity is a series of regular periodic payments, it means the payment or the receipts are being received at the end of the period. Okay, that is what we call ordinary annuity. Then the second type of annuity is annuity due. All right, annuity due. And annuity due is where payments or receipts are made in advance. Okay, are in advance. That is, they occur at the beginning of each period. All right, so that's the difference between ordinary annuity and annuity due. So that is to say that all payments or receipts under the annuity due are 1 year earlier than the ordinary annuity. Okay, so when you are given a question in the exams, you need to read it carefully to see if the payment or the receipt is being made at the beginning of the year or at the end of the year, or the payment or the receipt is being made after a service has been provided or not. If the payment is made after the service has been provided, then that is ordinary annuity. But where the payment is made before the service is provided, that is annuity due. Okay, but in this particular situation, we are talking about investments. So when are you depositing the money in an investment account? Is it at the end of the year or at the beginning of the year? That is the difference. All right. So know that difference. And this annuity will help us in calculating certain things. So we are going to get to those things in a very short moment from now. All right. So these are the formulas for calculating the two types of annuities. All right. So we have the ordinary annuity formula, the ordinary annuity formula. And that one, we are saying that it is this. So we have X amount, which is the initial or the annual investment you are making, multiplied by 1 plus R, bracket close, raised to the power n, or minus 1, or divided by R. All right, so that is the formula for the ordinary annuity. Now, the annuity due formula is the same thing, is the ordinary annuity formula multiplied by this factor here, 1 plus R. Okay, so that is the only difference between the ordinary annuity and the annuity due formulas. So in both cases, the X here is the initial or the annual investment, as I have already pointed out. So please know these formulas. Know these formulas. And the only way to remember formulas in financial management is practice. When you are practicing, you become so familiar with the formulas that it becomes very difficult for you to forget. Now, some of these formulas will be provided for you in the exams, but not all of them are going to be provided. So it's good that you know most of these formulas. All right, you know most of them. All right, so let's continue. So let's look at an example where this annuity concept is applied to what we call sinking funds. All right. So the annuity concept, as I said, can be applied in various situations. And the first one, or the most popular one we are going to look at, is the sinking fund. All right. Now, what is a sinking fund? A business may wish to set aside a fixed sum of money at regular intervals to achieve a specified sum at some future date. This is known as a sinking fund. So, a sinking fund is basically a fund in which a fixed sum of money is placed at regular intervals in order to achieve a certain target in the future. So that is what we call a sinking fund. So let's say that you are planning to buy a vehicle in 10 years' time, and you estimate that okay, if I'm able to put this amount of money in an investment account today, by 10 years time I should be achieving an amount that will be able to afford me the car that I want. That is an example of a sinking fund. All right, now the technique for calculating a future amount uses the annuity formula. All right, so let's look at this example and see what we have. Ernest, that's myself. All right, so I'm planning to set aside 5,000 every 6 months for the next 18 years, in a savings account towards acquiring an asset starting now, that is today, because I don't want to waste time. All right, the account pays interest of 6% compounding semi-annually. What is the balance in the account at the end of the 18 years? So, is this an ordinary annuity or an annuity due? Is it an ordinary annuity or annuity due? Now, read the question carefully. For you to be able to answer this question, you need to determine whether the payment or the amount involved, the principal amount or the amount of investment is being set aside at the beginning of the period or at the end of the period. So reading this particular question carefully, this 5,000 is to be set aside every 6 months, all right, for the next 18 years in a savings account towards acquiring an asset. Okay, so since we are setting aside every 6 months, it means at the end of every 6 months. Now, you should also know that whenever it is an annuity due, that is, the payment is occurring at the start of the period, it will be stated. All right, that one it is mostly obvious. But where the question is open-ended like this, then ordinarily it should be an ordinary annuity. All right, it should be an ordinary annuity, which means that the payment is made at the end of every 6 months, all right, for the next 18 years. So we have to calculate the balance of the amount in the account at the end of the 18 years. So let's see what we've got. So this is the solution here. So the future value is equal to this, and this is the ordinary annuity formula. If it is the annuity due, we are going to multiply this particular thing here by 1 plus r. Okay, 1 plus r. So this is the formula. The future value or the balance in the account, which is the future value, will be equal to x into bracket 1 plus r into bracket close raised to the power n or minus 1 divided by r. Okay, where x, so the x is the initial amount invested, 5,000. Now r here, we are going to use the equivalent period rate. Now let's go back to the question and see what we have. So the 6% interest rate here is on semi-annual basis, and this is based on every 6 months. So every 6 months, this is the amount you are going to be earning on the amount invested. But the calculation is going to be based on 18 years. All right. What you are considering here is 18 years, not 6 months. So we want to find the interest equivalent for 18 years. Okay, for 18 years. So that is what we are doing here. So to do that, we use the equivalent period rate, which is calculated as this. So when you are given the interest rate for a particular period, you can convert it into the desired period for you to do your workings. Now, why do we have to convert the 6 months into 18 into years? That is because the n here is the number of years we are expecting the money to sit in the investment account. All right, and the number of years here is not talking about your our 6 months. It is 18 years. All right, so we need to convert the 6% into an equivalent period rate of 18 years, and that is what we have here. So we have 1 plus the known interest rate in bracket close raised to the power 18 years times 2, because we are going the 6% is going to be applicable in every year. Is going to be applied twice. All right, so at the end of the 6 months and then at the end of another 6 months in the year. So that's why you are multiplying the 18 times 2. If it is quarterly, you are going to multiply by 4 the amount of years, the number of years by 4. If it is monthly, you are going to multiply it by 12. So as like that. If it is weekly, you are going to multiply it by 52 weeks. All right, so that is what we do it, and then we are going to subtract 1 from the result. And so when you do that, you should be getting 7.147%, or as preferred, we convert it into decimals to be able to get 0.07147. All right, So that is the rate that is applicable for the 18 years. And then we can now calculate the future value for the 18 years. So we have 5,000 bracket open 1 plus 0.07147 bracket close raised to the power the number of years, which is 18, minus 1, all divided by 0.07147. And then that will give us a future value of 242,360.27 cents. All right, so that is what we have for simple interest and compound interest and their application to sinking funds. All right, so you can actually apply this sinking fund in real life, not just for exam purposes. If you want to plan maybe a future investment, you want to buy something in the future, and you can actually do some calculations on your own by applying these annuity formulas to know how much you'll be having in your account before the period elapses, and then you should be able to determine if this is worthwhile or not. All right, so that is it. Now, in our next video, we are coming to look at discounted cash flow techniques. So be on the lookout for the video. Thank you very much for your time in this particular video. I hope you learned what we mean by simple interest, compound interest, and their applications in financial management. So if you see any question like that in the exam, please read it carefully and apply the formula appropriately. And then you can be able to obtain your maximum marks. All right, so I'll see you in the next video.